Time now for what is on Rob's radar. And in the wake of yesterday's EF1 tornado in Fort Myers, probably more than a few of you were thinking, how do tornadoes form in fact? A lot of people associate the collision of warm and cold air together as a way that tornadoes can develop. And though that does play a role, there's also something else that plays a perhaps even more important role, and that's something called wind shear. Now, wind shear is when winds in the atmosphere are blowing in two different directions and in two different speeds throughout the profile of the atmosphere. And what can sometimes happen as the winds change in speed with height is that they can sometimes almost do a somersault around themselves and form a horizontal rotating column of air, something similar to what like a paper towel tube looks like. Now, a horizontal column of air is not going to form a tornado because it is parallel to the Earth's surface. But if this horizontal column of air can become vertical, then we've got an issue. And that happens when air starts to rise underneath our horizontal column of air, when a shower or a downpour or a thunderstorm starts to form. Because as soon as that vertical column of air becomes established, that's what can form into a tornado. Now, here in the United States, we've seen firsthand how the size and scale and scope of tornadoes can vary quite a bit from one situation to the next. The big tornado in Kentucky a few days ago, that was on the ground for way more than 100 miles and with a really wide base, more than a mile. The tornado yesterday had a width of about 50 yards or so at the base, which is about average for this point in the year. But sometimes, tornadoes can be considerably smaller and they can still be very, very violent. Now, the tornado that moved across Lee County yesterday was in the Briarcliff community, at least initially, and in the 1.3 miles that it was on the ground, and in the span of only 2 minutes, it did nearly $500,000 worth of damage before it finally ended in the Eagle Ridge community by 6:27 in the morning. So let's talk stationary fronts. They're really important because fronts are one of a few things that can force air to rise. And when air rises, it cools and condenses into clouds and storms. Now, a stationary front on a weather map, as you know, is always marked by something that looks like this, with the alternating warm front and cold front symbols. Now, on this map of South Florida, you'll notice as our stationary front's been sitting kind of like this much of the week, what it's been doing is it's been keeping the cooler and drier and less humid air north of us in North Florida, while keeping all the warm and sticky air over top of South Florida where you and I are. Now notice what happens right here along the stationary boundary line. We're forcing warm air to rise up and over the cooler and more dense air. That's forcing the air to cool, and as it cools and condenses, it turns into the unsettled weather we've had around here with lots of clouds and lots of rain. Later this week though, we're going to get rid of the rain, we're going to get rid of the humidity, and we're also going to get rid of the stationary front, and all this cooler and drier air will at least temporarily be able to push here into South Florida, and you'll notice a few differences with that in our forecast. Well, it is time now for what is on Rob's radar, and I am bundled up today, not because of the cold temperatures that are coming up because of this week's cold front, but instead to explain why on earth the Pacific Northwest has been getting so much snow lately. And one of the biggest reasons why is what you can see behind me out here. The huge mountains that are found in parts of western Washington state. If you're not familiar with the terrain of Washington state, it's really, really rugged out here. I mean, there's an active volcano with Mount Rainier to the southeast of the city of Seattle, and west of Seattle, there's a whole mountain range out here known as the Olympic Mountains. Now, these mountains are on the order of 8,000 feet tall, which makes them about the same size as some of the mountains we talk a lot about during hurricane season in Haiti and Dominican Republic. You'll remember from hurricane season how those mountains in the Caribbean can help to disrupt tropical systems, but also enhance rainfall. Well, these mountains do the same thing. Now, they're not going to disrupt any tropical systems out here, but what they can and will do, and what they're doing right now actually, is helping to greatly enhance the rain and snow that's falling across parts of western Washington state. Just breathtaking out here, isn't it? So to put this together, let's use our imagination to pretend that we are hiking through the Olympic Mountains in areas of western Washington state. Again, pretty rugged territory out here, mountains around 8,000 feet tall. Now, in this part of the United States, the winds almost always come from the Pacific Ocean and then push toward land. Now, when the wind pushes toward land, it can't go through these mountains, so instead it's forced to go up and over the mountains. When it does that, the air starts to cool and it condenses goes into cloud cover just like this, and it starts to squeeze the moisture from these clouds in the form of rain and sometimes very, very heavy snow. And that's one of the reasons why parts of Washington state have gotten several feet of snow over just the past couple of days. So next time you see these images of incredible snowfall coming out of the Pacific Northwest, well, now you know exactly why it happened. Time now for a special edition of What is on Rob's Radar as we're marking the end of hurricane season today with the NBC2 Great Hurricane Challenge Quiz Show 2021 edition. We're going to see how much you can remember from this past hurricane season as Nate Foy takes on Kyla Gaylor. You guys ready?
If I'm a betting man, I got my money on Kyla. I'm not good with this stuff.
I don't know about that.
You'll be fine. All right, of the 21 named storms that formed this year, name the storm that came closest to southwest Florida.
You want to go first?
I'm going to go with Elsa.
I was going to say Elsa as well.
Very good. Yeah, Elsa gave us an awfully close call in the month of July. It was kind of an early season system. The center of the storm went parallel to our coast, and it brought a bunch of flooding rain to parts of Sarasota and Charlotte counties. Some communities, like in Englewood area, got more than a foot of rain. Wow. Next question. Remnants of what was once a big hurricane, Hurricane Larry, produced more than 2 feet of blank in Greenland. Was it more than 2 feet of snow, more than 2 feet of storm surge, 2 feet of rain, or 2 feet of sea foam? Do you remember?
I definitely don't, but...
I'll let you take this one first.
Yeah, I'm going to go with rain. Just keep it simple.
Take a guess, Kyla.
Okay, my gut is saying storm surge, but I'm going to go with sea foam.
This was an interesting one. It's only happened a handful of times, but the remnants of Larry, which formed off the coast of Western Africa, as it moved into the northern latitudes here, it combined with a front and dropped more than 2 feet of snow in parts of Greenland. And NASA had a great demonstration of this, especially here in parts of the southeastern part of the island. They had more than 2 feet of snow in the month of September from a former tropical system.
In retrospect, makes perfect sense.
Yeah, it's always the most logical answer.
All right, and last question. How big were the waves in the Atlantic Ocean during Hurricane Sam? This was a big storm. The waves could have been pretty big. What do you think? 7 feet, 50 feet, 70 feet, or 30 feet?
So, if I remember correctly, Sam was Category 4.
It was, yeah.
I think so, based off my quick research before doing this segment.
Right.
I'm going to go with 7 feet.
I'm going to go with 70 feet.
It was a big one. Not quite as big as 70, but 50-foot waves. And the reason we know that is not only from the satellite, but from also a sail drone. This was the first time in human history we were able to put a drone that looks like a big surfboard inside the path of a huge hurricane, and they were able to measure and study these 50-foot waves in that part of the Atlantic Ocean.
I can't even imagine 50-foot waves.
So if I was a little bit closer, so that means I technically won.
I guess we'll give it to Kyla.
Yeah.
Either way, we all win because we all avoided a hurricane strike this year.
Yes.
And of course, we'll be with you every step of the season next year as hurricane season 2022 starts on June 1st. Well, it is time now for What is on Rob's Radar. And what I'm thinking about today is the planet Earth. You know, the news, you've heard a lot about this big climate summit that's happening over in Scotland for the past couple of days. So I thought we should focus on one really important piece of climate data that comes to us thanks to the help of satellites. You know, there are literally thousands of satellites that are orbiting the Earth every single day. And though a lot of them have something to do with the weather or climate, most of them, of course, have other purposes. But the satellites that are focused on weather and climate, boy, have they been gathering some really fascinating information over the past couple of years. You know, one of these satellites goes by the name of Grace, and what Grace has been doing since it was launched into orbit back in 2002 is gathering some pretty eye-opening data on what's happening to the ice on the island of Greenland. In that demonstration there, on the right-hand side of your screen, what you see is the rate of ice loss in Greenland going from 2002 to 2020. On the left-hand side of your screen, what you see on that map is showing you where in Greenland the most amount of ice has been melting. Now pay close attention to that color table. When you get into the shades of red and orange and brown and eventually black, that's showing you an incredible rate of ice loss, in some cases more than 16 feet in less than 20 years. That is a lot of ice to melt in less than 20 years. To try and put this into perspective here for you, this big TV set behind me is 10 feet tall. You'd have to go all the way up here, up 10 feet, and then add on 6 more feet to get a perspective as to just how much ice has been melting in Greenland that goes back to 2002. And again, I want to stress, this isn't projecting out what's going to happen in the future. This is showing you the ice that's already melted in the span of less than 20 years. Well, it is time to talk about what is on Rob's radar. And yesterday, something incredible happened on the westbound lanes of Alligator Alley. Well, what you see right there, that blue Nissan was struck by lightning. And the lightning went from the antenna all the way into the road and cut, I believe it was a 7-foot gash, you could almost say, across Alligator Alley. Now, that gentleman there in the shorts, he was inside the car at the time. So how was it possible? How could he be alive? Because he was almost struck by lightning. The reason he's able to walk around right now is because he was inside his car, not outside it, not touching the outside of it, but safe inside his car. You see, your car is actually a very safe place to be during a thunderstorm because it really helps to protect you from lightning. So let's pretend that this red car here is our car. And just like yesterday, let's pretend the lightning strike hits where the antenna is right here at the top, right here. Now, the initial part of the energy is going to go into the car, but something happens called a Faraday cage. And what happens is that instead of the energy from that lightning bolt going inside the car and electrocuting anyone who's inside the car, what the energy wants to do is travel around the car, completing something called a Faraday cage. And what happens is the energy moves around the metal frame and then it gets sent right into the earth. And that's what caused that 7-foot gash on the westbound lanes of Alligator Alley yesterday. So even though it might sound crazy that he was only a few inches away from that bolt of lightning, he was very safe inside his car. However, had he been standing outdoors and resting his hand on the car and then it got struck by lightning, he would have been part of the Faraday cage and he would then have been struck by lightning. So if you have no other options when you're outdoors and a thunderstorm is nearby, get indoors, roll up the windows and hope the storm goes away. But even if your car is struck by lightning, you at least have some safety measures in place thanks to something called a Faraday cage.